Alright, so this is the second part of your groundwater lab. Our first thing here, we've got a groundwater model. We've got an aquitard, which is a clay layer that is impermeable, right? So that means no water can pass through it. We have a confined aquifer. It's a little more coarse gravel. We have an unconfined aquifer. Here, that's a sandy layer, a little more gravel and sand mix. We have a fine aquifer up here, a nice fine sand. We have the discharge area over here, which means that's where the system's losing water, right? We have the recharge area, which is probably kind of hard to see on the video, but this is the recharge area over here, so that's where the water is coming into the system. We have various wells that go down to different depths and into different layers. And even beyond the aquitard, we have a couple of wells that drop down. So what we're going to do is see what happens when we introduce a contaminant to this system. Well, first we'll start with marking the water table on this model. So the water table, as you know, is where everything beneath it is saturated with water. So all the pore spaces are filled with water. So let's start by marking up our water table right now. So you can see we've got water here in our spring, or in our river. And then here's our spring. The water level in the spring is right there. Our second spring is actually up here. We've got a change in elevation, but our water level is here in this one, so let's connect that line. And then we go up here. There's another one there. Water level's here, there, and then the lake. And then I'll start with these wells and work backwards. So my water level is here in this one. So I'll just connect those lines. Here in this one. And here in this one. Okay, so that's our current water level. Now let's say we increase the flow. So we increase the recharge. Let's watch what happens to our water levels then. Okay, so we can see our water level is rising. It's rising in our lake as well now. This one's moved up to here. This one's up to here. This one's moved all the way up to there. So all of our water levels have now risen from increasing our recharge. I've increased the discharge, and you see they're falling rapidly just by increasing the discharge. So let's go ahead and get this stabilized again. Keep knocking my houses off. Okay, I think we're pretty close to having our water level back where it was before. So how do you think you can measure the water level in the real world? Obviously you can't cut a cross section of the earth and see it like this. But what are some things you think you could do? I mean, we're capable of drilling wells, right? And we're also capable of measuring the water level in wells. So perhaps you could measure the water level in all the different wells. Drill a variety of wells, measure the water level, and that would give you a good indication of what your water level is, and actually that's what hydrogeologists can do and do. So why do you think we had that change when I increased the recharge? Why do you think we had the change in the water level? Think about it for a minute. The water table itself is really based on your recharge and your discharge, right? So there's a pressure differential that's happening there. You've got water coming in, it's pushing water through, and then water is leaving the system, and when it balances, you've got about the same amount coming in as going out. You can see I've even got a little more going in than out now because my water level is still rising slightly. Okay, so what we're going to do is we're going to introduce some dye into some wells. We're going to calculate the velocity of flow of our system. That is the amount of water coming in and flowing through our system. And velocity is calculated by distance over time, so distance divided by time. But first what we're going to do is we're going to pull some sand or some water out of the fine aquifer. So this is our fine aquifer here, this fine layer of sand. And I'm going to put a syringe in here and draw some water out, and then we're going to watch what happens to this water level. So I'm pulling water out of this, and my water level now in this one is down here. So what happened there? Let's do it again here and see. I'm drawing water from this well, and now this well is down here. It's starting to rebound a little bit, but it dropped really rapidly when I pulled water out. There's a name for that. Hopefully you've been through that in lecture. So let's see what happens when I go into the coarse sand aquifer. I think this one takes me into there. So I'll go ahead and put this one in here. And I'll draw water up. Again, our water level on this one. Oh, my contaminant barrels fell. Okay, our water level on this one is actually up here now. So we must have a little more recharge going in than what we had originally. Let me draw from here. Oh, and the water level dropped, but it's rebounding right back. Let's try it again. I can show you where the water table ends up. Yep, it went right down, and now it's coming right back up. Alright, so let's go ahead and do velocity calculations. And we're going to start out in the fine sand aquifer. Now, you had a timer of some sort before, whether it's your watch or your iPhone, again, to do the minutes and seconds. So I'm going to do the measuring part. I'm going to introduce the dye and do the measuring part, and you're going to do the timing part. So let me get a little bit of dye in my syringe. We'll call this a contaminant. So I've got my barrels of contaminated, barrels of toxic red waste. And I'm going to introduce these into a well. Alright, we're going to do this in the fine aquifer, so that's right here, well number 3. And again, when I tell you to go, you start your timer, and when I tell you to stop, you'll stop it. Alright, ready? set, go. And you can see this is what they would call a plume if it was a contaminant. So our dye has been introduced into the sand, unconfined aquifer, the fine sand aquifer. And if you're watching it, think about which way it's going. It is moving down a little, but primarily it seems to be moving with the flow of the water. So take a look at that thing of the flow direction and the movement. We've moved down probably about 3 inches, over about 2. We're going to go with just the straight over though for velocity because we're following the path of the water. So I'd say we're at about 2 inches now. So let's go ahead and stop the timer. Now again, to calculate velocity, you're going to put distance over time, so that 2 inches over how many ever seconds that your watch was at, and that's going to tell you how fast the water is flowing. Now, again, think about it for a minute. If you've got recharge coming in, this water is coming in here, and discharge is going out, so it's going out there. So which direction is your water flowing? Is it flowing from recharge to discharge or from discharge to recharge? That might be a question that you need to think about. Alright, so go ahead and calculate your velocity for that one. And think about what happens to the contaminant that I put in there. So, you think it got darker? Or did it change color at all? Did anything happen? It started out kind of a small bubble there, and now it's pretty big and spread out, but what happened with it? So think about that for a moment. Let's see what happens when I try to withdraw a little bit of it. I'm going to rinse some of this out of here so that I'm not introducing more. I missed most of it, right? But you can see up here, the sand is almost clear, right? And then it gets pink again. The water I'm discharging was pink. See the water in the tubes. The tubes dyed pink anyway, but you can see in the syringe here, the water's pink. Alright, notice what happens too when it hits the aquitard. Okay, so let's see what happens when we try this out. in the coarser sand. I think I'm going to have red fingers for a couple days. Alright, so let's try it out over here. Move my little well to where the other wells are. Alright, so reset your timer to 0. Ready? Set. Go. So again, I start out with my little plume here. See, it's already over here. Alright, stop. I'm at 2 inches already, which is what we had on the first one, right? So check out the time for that. That was... yeah, it's already at 2.5. It's moving pretty rapidly right across this coarse gravel mix. Sand gravel mix. Okay, so again, think about which direction that dye is flowing. Is it flowing from recharge to discharge or discharge to recharge? And what's happening to the dye? You know, I kind of started out and that clump here was real dark. I'll clean the tube out a little bit here, get some of the dye off. Get the syringe nice and clear again. See, the syringe is very clear. So what's happening when I do that? See if I move my little cows here. Well, look at that well. Alright, so go ahead and 0 your timers again. We're going to try one more. Alright, so I'm going to come back over here. I'm going to go beneath the Aquifer into this coarse gravel mix. Alright, so you ready? Start your timer. Again, you can see we've got a nice dark plume right there, a contamination. We are already at 2 inches, so stop, well, we're at 3 inches, stop your timer. Again, calculate the velocity, distance over time. You just divide it out, and that'll give you inches per second. Look how fast that's moving. Again, I pull it back up. Oh no, I knocked over my well. See what happens right around the bottom of this. See what happens when I'm pulling it out. So, I'll go ahead and stop this now. You can start to answer some of the questions that are on e-learning in this section. And then we'll take a look at one more groundwater model just to see how a contaminant would move through a fractured aquifer.